Hello everyone, welcome to QA Labs for you. This is episode 3 of QA SAMVAAD season 2. Today we have a special guest, Mrunal, with us. He's having extensive experience into the performance domain. So in this episode, I'm trying to get more details about performance world as well as see how exactly, tools and tactics can help us to grow into the performance world. So let's welcome Mrunal. Hi,
Hi Srikanth,
how are you?
doing great Srikanth, how are you?
All good, all good. So, for our audience, if you could share a little bit about your journey so far, that would be better.
So I started my career with Wipro Technologies right out of college, joined Wipro as a fresher, and I was trained into performance testing, so I continued from the beginning. I've been into performance testing. So from Wipro, I worked with Wipro for around 3.5 years, then moved on to Wells Fargo, where I did 2.5 years, close to 2 years, I think. Then I joined Sapient, again another 2 years there. And in 2018, I joined Techion, which is my current company. I've been with Techion since 2018. It's almost 7 years now. Here, I'm leading the entire performance team. There is one single team that caters to all the products that Techion builds, and I've been working. I'm handling a team of close to 18 people here at Techion. So that's my journey.
Good, good. So, Mrunal, I was checking your profile. I guess you are from mechanical background, right?
Yes,
Yeah. So, how
I
you
did my yeah.
mechanical to, IT?
So yeah, I finished my engineering in 2009,
Mm-hmm.
and it was in mechanical engineering. And at that time, I did want to get into a core company,
Mm-hmm.
some mechanical company, but recession was at its peak during that time, 2008-9 period, and the scenario was like any job that you get, you have to grab it,
Right.
right? So I took it up. Wipro came for campus hiring.
Mhm.
I luckily made it, and I took up the job. So that's how I landed in a IT company, even when I was from a mechanical background.
Great, great. So, you moved into IT, that is fine. But what I have seen mostly when someone, came into IT, either into dev or into QA, especially if someone move into QA, he start from manual testing or functional testing, right? Then into automation. But I guess you started from directly from the performance, right? Or
Yeah.
or any other
Yeah.
area.
So in Wipro, once we joined, they trained us in a lot of things. Some part Java, some Linux. They try to make us. They try to train us in any
Auto.
field that you would go to.
Yeah.
Uh, so then they put us in specific buckets. Okay, some of this large group will go to performance. Some of them will go to automation. Like that, I was in the group that had to be sent to performance testing, specific training, right? So I ended up in that group, and that is how it continued. I was trained further into performance testing, and then I got all performance testing projects, and that is how I continued.
Great, great. From I guess 2009, right?
I finished my engineering in 2009, but I got a call from Wipro to join in 2010 Feb.
Okay. So from 2010 to 2025, okay.
Yeah.
How this performance testing or this area has evolved? Can you just, share your thoughts?
Quite a lot, I would say. When I joined,
Mm-hmm.
the more dominant, there was a tool called Load Runner. It was synonymous with performance testing. If you asked anybody about performance testing, they would just start talking about Load Runner. So it was that tightly coupled, right? Load Runner and performance testing were thought to be the same. But now, so many new open source tools have come, so many ways to do performance testing have come that Load Runner is almost obsolete now. Only large enterprises that are able to afford the licenses that Load Runner offers. Most of the product companies or startups are trying to use open source tools,
Right.
right? It's a large change, and I would say industry has been moving towards open source more and more than any license. There are still a lot of licensed tools. Load Runner is the biggest one, and next is Neoload, and couple more paid tools are there. But overall trend is that people want to move to open source tools.
Agree with your thoughts, on this part. So, Munal, in 2025, if someone wants to start the performance testing, right? So, what
Mhm.
are things he has to learn first? So, what should be the roadmap for any new guy who wants to start into the performance?
When I started out, The
Mhm.
focus was more on learning tools, right?
Right.
As I said earlier, tool was synonymous to performance testing, but that is where I made a mistake at least. Tool is not equal to performance testing. Knowing a tool is not equal to performance testing. Performance testing is a wide, like it's a vast area. You need to know tool. That is one part of it. But when you apply load through the tool, what happens? That you need to know. You need to know a little bit of system design, how
Mhm.
your system architecture has built, where all can performance bottlenecks occur, that you need to have an intuitive idea. I'll come to how you can grow that intuition. You need to know basics of your OS operating system. What is a process, what are threads, how is management done, right? All of these are also essential. And some amount of statistics is also needed because the results that these tools give you, right? You have thousands of samples
Right.
and results you look are in terms of averages or percentiles. You need to be able to understand what those numbers are telling you. And there are tools that help you understand performance characteristics. These are called APM tools, application performance management tools, that your application uses to send its metrics. Right? You need to be able to read the metrics from those tools and understand what they mean and how it talks about performance. So if you ask very basics or the fundamentals to start with performance are, you need to understand how any OS works, at
Okay.
least the fundamentals, right? What is a thread? What is a process?
Mhm.
What do they actually mean? How does memory management happen? Some amount of system design, because recently architectures, as I said earlier, a lot of open source tools have come. You need to know what each piece of architecture does. So for that, you need to know system design and a little bit of infrastructure knowledge. And any open source tool, JMeter, K6 are really good to start. Tools and some amount of statistics. You need to understand what is average, what is 95th percentile,
Right.
what is standard deviation. All of these things would constitute some fundamentals that you need to know when you begin as a performance tester in this year, 2025.
Fine. And for our audience, because maybe someone is fresher, right? So can you just explain some of the types of performance testing with real-time example, I mean, because theory we can
Yeah.
get from internet, right? But real-time exposure we can't get.
Yes. So this might sound similar to what you have read, but I'll anyway try to add some more color to it. There are three, four main types of testing. Each one has its own specific goal. Okay. When we say different types, each test has a specific goal. First is very basic test, which is called load testing. What you do in load testing is you either the current load in your production, or if it's a totally new, you anticipate some load. Okay. You make an informed guess saying, okay, this might be the number of people who land on my website, or these many hits my website may get. So you start with that number. That is your load test. You're just trying to understand your application under load. Next is stress test. We all have been through websites going down under sale load, right? We have seen this with Flipkart. A lot of websites go under load. That is the scenario of stress.
Okay.
What happens? The website gets more load than it expected. Okay, that we test through stress test. We are essentially trying to break the web application or whatever website you're testing. We're trying to increase the load until a point it breaks and observe what caused its shutdown or what makes it go down. And there is another very common test called endurance test. It tests what happens when you have a constant load for a long time. Let's take again some e-commerce site. It will have some peak load during some time of the day when people are casually browsing. Let's say 11 a.m. in the morning, it could be a peak time for an e-commerce site. People are just browsing. And at night, that load will not be at that high level throughout the day. But there is minimal load throughout the day and even throughout night. So we test for that. When what happens to the application when there's a constant load for a long duration. There are other types of tests specific to the use case. For example, there is something called as spike test. What you do is these flash sales, right? There would be some mobile device that is on sale at a particular time, and everybody logs into that website at that particular point in time. So that is called a spike. You try to simulate that kind of load where all the users are going onto the website at the same point in time. So based on use cases, there are different types of tests. You can bring up a newer kind of test tomorrow, right? Based on your use case. So it all depends on what problem you're trying to solve through performance testing.
So, Mrinal, I mean, one question is coming into my mind because I also performed, I mean, some kind of performance test using JMeter. So at that moment, I was using API. So is there any way to do the performance testing from the web or from the mobile, from the UI perspective? That is also possible, I mean?
So modern websites are built in such a way. Okay, so you have have your websites that for which HTML gets generated on the server side and it is delivered to the browser. In this, the test that you're running is trying to hit the server that is generating those HTMLs.
Right.
Some websites are built on Angular or React where front end is hitting APIs. In both these cases, these tools like JMeter, K6 are useful. They can simulate this kind of load. Now, if you're specifically talking about measuring UI performance, there are tools built for it. I know of two tools. There is one is called web page test. Another one is called site speed. Okay, these specifically measure UI performance. They are not load generating tools, as in they act only on your UI wherever on a single UI.
Okay.
When I talk about cases, they generate load. They generate thousands of hits per second or thousands of users logging into some website. But the UI measurement tools, they work on one client, one browser client, and measure UI performance. It is possible to measure UI performance using these tools. Some inbuilt tools are also there in Chrome. It's called Lighthouse.
Okay.
But it's only for one page at a time. With some scripting, you can achieve some flow testing. JMeter and a couple of tools have this capability, UI performance capability. But I think they are dependent on Selenium, which is a very heavy driver. It may not be accurate results.
And Mrinal, I mean, during the conversation, you have used the term bottleneck, right? So, what are common performance bottleneck? I mean, can you just elaborate a little bit? I mean, for the audience.
As the name suggests, right? Imagine a bottleneck. You have a bottle,
Yeah.
and at its neck, it's narrowing down, right? The water, when flows from the bottle to the neck, it gets constricted, right? The
Right.
simplest definition is a bottleneck that you see in a bottle. So, bottleneck is anywhere where your resources are constrained. Okay, your whatever work you're trying to accomplish is being constrained because there's not much resource for that task to happen.
Right.
So that's a bottleneck. I have seen there are very common bottlenecks. Okay, the most common ones I have seen is, I mean, this is very common. People miss out on adding indexes, right? Initially, when the data size is very small. This is the bottleneck at the database level. Initially, when the data size is very small, it doesn't matter. Queries are very fast, right? As the data volume grows, your query has to do a lot of work to fetch the data that you are looking for, specific data that you're looking for. In this case, adding indexes speeds up your queries, right? Without people generally don't realize that as the data volume grows, they would have to add indexes. And from what I have seen, they yes, we have to add indexes only when they see some problem in query, right? Slow queries.
Right.
So that is one of the common ones I've seen. There are problems related to threading, right? Threads being blocked or insufficient number of threads. Let's say some service is running and you're trying to hit some API at a certain hit rate, right? If it doesn't have enough threads to accept all that work, you will start the request will start queuing. So these are some of the common bottlenecks. There are ways to observe this and pinpoint at these.
And I mean, during the performance testing, some of the common terms like throughput, latency, right? So can you just explain in one line for the audience?
Sure. Throughput in very generic terms is much work you are able to do in unit time. Okay. It is the same in case of physical world. It's the same in case of virtual world. If I'm able to write 5 scripts a week, my throughput is 5 scripts per week, right? Its unit is work done per unit time. So if you are able to process 10 API requests in 1 second, your throughput is 10 requests per second, right? If you are able to store 100 GBs of data in 10 minutes, your throughput is 100 GB per 10 minutes. Right? This is a simple definition of throughput. If you come to latency and response time are similar. Many people use them interchangeably, but response time is end to end. The moment you start some transaction from your UI, it passes through the network, it reaches your server processes it, and gives you back the response on your browser. This entire end-to-end round-trip time is called a response time. Latency is maybe just one way from your browser to the server. That time, if you measure, that is latency. But people generally do tend to interchange response time, use interchangeably response time and latency.
Got it. And I mean, what should be the ideal response time in order to consider as a good performance?
So
Any?
it depends on the use case of the web application. If I have a e-commerce website,
Mhm.
I don't want my customers to be frustrated with slow response times, right? So people's attention spans are continuously reducing, right? Maybe 5 years back, people were okay with page load time of 2 seconds. Nowadays, it's probably reduced to 1 second, right? So it depends on the type of application. If you're using a stockbroker app, right, you wouldn't wait for it things happen there in milliseconds. So for a stockbroker app, the response times are probably in milliseconds. So it all depends on what kind of application you're dealing with. You should ask these questions to your stakeholders who is giving you this performance testing work, right? You should ask the question, what should be the SLA? How
Oh,
much is the acceptable response time for any given particular transaction or API? I usually do that. I ask that question to whoever comes to me with that request. So it's not something that is standard. It varies from industry to industry. It varies from application to application.
so, Mrinal, I mean, while searching about this performance testing, I have also, I mean, heard about this cloud native performance, right? And we are doing performance testing in-house also. So, what is the major difference between these two terms? I mean, I have used the performance testing in my own office, right? So, in my local machine, I can say. But the new term that is coming, like cloud native. So, what are the exact differences?
Cloud native means that you started building something
Mm-hmm.
on the cloud itself. Cloud native, the terminology is being used because when cloud was newly, being adopted,
Mm-hmm.
a lot of applications were on data centers. People were hosting their own applications on data centers, and use case of cloud started making people. I mean, when cloud started getting adopted, people started moving their data center hosted applications to cloud. This was called as migration. Nowadays, applications are being written directly on cloud. That is called as, those applications are called as cloud native applications. Now, testing an app that was directly built on the cloud is called cloud native performance testing, right? It is specialized in the way that your tools also have to be on the same cloud to avoid any latency issues. Because if my application is in the cloud somewhere in US West,
Mm-hmm.
and my tool is running in, say, Bangalore to US West one, there's a huge amount of latency, right? That will add, like, it's a false metric. It will get added to my, that additional latency will get added to my response time metric, which you don't want, right? It gives you a false metric. So when you say cloud native testing, you're also hosting your test very next to your application and testing right from the same cloud where your application is running. May not be the same VM.
Mm-hmm.
It should be present in the same VPC or whatever, right? And on-prem or data center,
Mm-hmm.
uh, I would say, again, that difference comes wherever you're hosting your application in a data center, in a on-prem data center. It is preferred that your load generator tool is also running in the same. There are some challenges with respect to cloud. These are not specific to performance testing,
Mm-hmm.
but these are generic.
Common.
Like, you have something called as stolen CPU, right? Your app may be running in a VM on a shared hardware
Yes.
in the cloud. So your neighboring app would be demanding more and more CPU, and that CPU is being stolen from your application. These kind of things are specific in cloud,
Mm-hmm.
right? So you have to be careful to measure those metrics. There's a metric called stolen CPU.
Mm-hmm.
So we have to monitor those when we are running tests in the cloud, so that we are sure that whatever response time we see is purely because of our app's work and not because some other app is trying to steal CPU from my app. Cloud has its own challenges in terms of performance. So this is one of those.
Okay, fine. And I mean, in the current scenario also, I have seen in most of the applications, organization are using some monitoring tools, right? So do you think if we are already doing the monitoring, then in that case, this traditional performance approach is still required, or the monitoring can help on the traditional approach for the performance? What's your thought?
Yeah, I would say both are complementary to each other. They are one cannot replace the other because production monitoring is something that happens after the fact, right? By the time you monitor something in production, you have already sent the code to production, which means your customers are using it. If a performance bug happens to be in production, it means your customer has discovered it. You don't want that, right? You want to give your customer a good experience from the perspective of performance. So you don't want it to reach production. If we do performance testing beforehand, find out whatever bugs we can, and then send to production, you will see less number of performance bugs in production. So having performance monitoring tools alone doesn't guarantee that you will discover all performance bugs. At the same time, running performance tests itself doesn't guarantee that all performance bugs will be caught before app is sent to production, right? It's a complementary, both are complementary to each other, both go hand in hand. Your entire performance management strategy should be that you test as much as possible, rest you send it to prod and monitor. And at the same time, as soon as you discover that something, there is a performance bug in production, that has to be an input to test that from the next time, right? APM tools should give you that input. It's a feedback mechanism that you incorporate and include that new bug that you found in production in your next test. So as I said earlier, both complement each other. Both cannot be separated, or one is not enough than the other.
Right. And one more thing, Mrinal, coming into my mind, because we are talking about 2025, right? So in the current scenario, I have seen, this microservice based architecture is being used, right? So is there any difference on the strategy for the performance testing on this new architecture, I mean?
Yeah, microservices differ from traditional monolith applications in that you have multiple services talking to each other, and there is additional latency involved when one service talks to another service. Let's say I had a monolith, I break it into 10 microservices. The monoliths will usually be better than when I test the application as microservices. That's because each service has to make an additional, if it was a monolith, communication between each of the services would be in nanoseconds or microseconds, right? When we break them up into microservices, the communication between each service happens within milliseconds, right? So you have additional latency coming in when you introduce microservices. So that is when you're breaking down an application into microservices, that is because to maintain it better, right? So you have to accept this trade-off of increased latency.
Okay.
You have to find ways to reduce that latency. There are multiple things that people do to reduce latency between services, right? There are multiple strategies, but essentially it is an accepted trade-off. Latency addition is an accepted trade-off of microservices. You have to live with it for flexibility of deployment, for maintenance and all that. So you have to, when you're testing microservices, you have to keep in mind that this additional latency will always be added. It'll almost never be equally as performant as, say, a monolith, equivalent monolith.
I think this is a very valuable point because most of us are not aware like this additional latency can disturb the performance metrics for this microservices. One more thing I want to ask because we are going deeper, right? So I just want to understand from your experience what all common mistakes teams are doing right now while doing the performance testing. I mean, whether it's execution, whether it's a script creation, right?
So some of the common pitfalls are that it's not similar to functional testing because it involves scale, right? You're trying to create a load or test your functionality at scale, right? That is the first change people have to think about. Now, some of the things that are valid for functional testing are also valid for performance testing as well. You have to always use random data so that when you use repeatedly the same data, there are things that it may be cached in your service. When you have caches built, your response times becomes better and better. So you
Right.
have to incorporate or you have to offset the effect of caching, meaning you have to test with both caching and no cache so that you get a real world response time. The one that I mentioned earlier, if your application is running in the cloud, you should be running your load generation from the cloud very next to the application that you're testing. Otherwise, what happens? Additional latency, like the example that I gave earlier. If your application is in US West 1 and you're testing from Bangalore, Bangalore to US West 1 latency gets added,
Added.
right? And that shows up as high response time, which is not the actual case,
Correct.
right? So that is one pitfall I have seen that people don't think about this where they're running their test from. Third thing is people think that performance test can be done at a click of a button, but it's much more than that, because when you're running performance tests, you need to have a very controlled environment, because we are dealing with thousands of samples. When you run your performance test, you're hitting the application thousands of times, right? And that the every time you hit, some amount of metrics are collected, so that those metrics have to be analyzed, right? It's thousands of metrics you have to analyze. If you are not controlling the environment, any small change in any variable, say in between your test somebody changed the branch, up to that point you'll get different set of metrics. After that point you'll get another set of metrics, right? So you'll then be in a dilemma, which one is correct, right?
Correct.
So you need to have a controlled environment where you can perform these tests, and you should put controls where nobody else changes anything during your tests. The tests have to be very, very controlled. Performance testing means you are running things in a controlled environment. So these three common pitfalls I've seen that people don't care of.
I want to add one point, Manal, on this, specifically for the environment, which I have seen. Like for the functional or for the automation, we have environment, right? We used
Hmm.
to do the automation, execute the flows. That is fine. But I have seen sometimes, I mean, performance team is also using the same environment. So because of that performance test, that environment get down. Okay, so it impacts the, I mean, the work of functional as well as automation team. So,
Hmm.
for this performance, do you think separate environment should be considered
Hmm.
while testing? I mean, this can be a, I mean, mistake which, I mean, professionals are doing right now. I have seen this thing because.
It is ideal to have a separate environment,
Mhm.
but separate environment comes with its own
Cost.
cost, right?
Yes, yes, yes.
It is a concern among many people,
Right.
many companies, right? So as much as possible, it is good to have a separate dedicated performance environment, because of the reason I stated earlier. It needs to be a controlled environment.
Right.
uh, if that environment is shared between functional QA or QA automation,
Yeah.
there are chances that they'll overstep your tests, right? And you also break the environment, and they'll be blocked for a long time. So as much as possible, a separate environment, dedicated environment for performance testing is preferred. But again, because it adds cost,
Yes.
it is a that has to be taken by management or leadership.
Right.
I mean, if as an engineer you are asked whether you need a separate environment, your answer should be yes.
Right, right, right. I mean, for that reason, we have to do this performance activity at the, I mean, day and time, because during the daytime performance, I mean, if we do the performance, it will impact the functional as well as the automation engineers. So it was the
Yeah,
strategy that team will work. I mean, rest of the team will work on the daytime, and after the day, we should proceed with the performance test. Because of that reason, I mean, the costing reason. So that is very
yeah.
valid point.
Many teams do this. Yeah, they have a time shared environment so that one is not stepping on the toes of other.
Okay, so Manal, I mean, we understand the importance of performance testing. As of now, we got to know about different types of performance testing, different types of tools, right? But I want to understand, when should we start the performance testing?
That's a good question. Modern applications are all moving towards CI/CD, right? We want to deploy applications using CI/CD,
Hmm.
and people are all shifting left, right? Shifting left means moving your test activities closer to development. So performance is also one such activity that can be moved towards development, but at a smaller scale. You cannot do end-to-end performance very close to the application development process. So how I would approach that is breaking up your performance tests from smaller tests to larger tests, right? Smaller tests could be one single API or couple of APIs. That could be done as and when the application is built, right? And as you go farther and farther from the development process, you could add more and more complexity, like adding an entire workflow. That could be done in later stages. So it is good to find performance bugs very early in the process by testing at a small scale. And as you progress through all the test stages,
Hmm.
you can do full-blown longer tests, because some of the performance bugs are only found with integration, when one service talks to another service, or when there is a bigger workflow only, and a long-running flow. Only then some of the performance bugs can be unearthed, right?
Right.
And extending this farther, right?
Mm.
I mentioned earlier, you cannot catch all performance bugs with testing. Some of them will eventually be caught in production. That is where your performance monitoring also comes into picture.
Fine. So, Munal, I mean, we talked about this shift left thing, right? Because it can help. So, in a similar way, right now, AI is also, I mean, in the picture. So, do you think AI is also helping, I mean, the performance activity anywhere as of now from your experience?
Yes. Script generation or script writing is a big part of performance testing. I
Okay.
think AI can be very, very helpful in
Mhm.
speeding up this generation process, right? AI can help in creating those scripts faster and faster. Okay. On an average, workflow with say 15 steps
Mhm.
could take half a day to 1 day of scripting effort.
Right.
I think AI can help in solving this scripting, reducing this scripting time. There are plugins for JMeter. There is a person called Naveen Kumar.
Mhm.
He writes plugins for JMeter. He
Mhm.
has recently written a plugin which helps you write some custom code. There are some string manipulations or some manipulations that you need to do in your JMeter scripts. The code for that is generated by AI. In my opinion,
Mhm.
AI can help generating the script, but when it comes to running tests, it depends on context, what you're trying to achieve with the test. I think some manual input is needed there. And
Okay.
also, while interpreting the test results, you can speed up the process by taking help with AI. You can ask it to summarize what the results mean. But ultimately, understanding what those numbers mean, a
Mhm.
human would be able to interpret that better.
Okay. And you have also used the term CI/CD in the performance part, right? So can performance testing be automated, I mean, as a part of CI/CD?
Yes, as I said earlier, shifting left, we can hook up some smaller scale performance tests as soon as the build is done. But as I said, it will be smaller scale because at that level, you cannot simulate big full blown tests, right? And breaking up your entire performance tests into smaller chunks helps in CIC. As you move towards the right, you
Hmm.
can run bigger, you can hook larger and larger tests. You can automate that, provided you have a controlled environment. Again, controlled environment plays a big role here. When you're hooking up larger tests to CI/CD, it happens to the extreme right of the CI/CD pipeline, and that is where you can run larger tests. So, as I said earlier, to be able to accommodate your performance testing into CI/CD pipeline, you have to break down your entire test suite into smaller, from smaller to larger.
Mhm.
Smaller goes to the extreme, larger goes to the extreme.
Munal, I want to know about one more word that is chaos engineering with respect to this performance part. So, I mean, can you just share some of the thoughts on this?
Chaos engineering or chaos testing is a new discipline.
Okay.
It originated at Netflix. The engineering team at Netflix was setting up this large scale
Mm-hmm.
cloud deployment on Netflix. They have global customers, right? They have millions of customers across the globe. So they wanted to be able to predict what happens when something crashes unexpectedly. So usually what happens is we test with keeping in mind that okay, nothing will break. Everything will work fine. But there are a lot of, when it comes to production, there are a lot of unexpected things that happen. For example, going back to Netflix, they were hosting their infrastructure on AWS. Right? Nobody would have predicted that AWS itself can go down, and that is what happened with them. And that is when they thought, okay, what if an unexpected event like this happens? How do we handle it? That is when they started doing chaos testing. Chaos testing is nothing but you try to, I mean, in fact, their chaos testing tool's name was called Chaos Monkey, right?
Okay.
It exactly acts like a monkey. It
Mm.
just stops network somewhere, it brings down some VM somewhere, right? And they gather data as to what happened when this unexpected thing happened.
Okay.
And based on that, they try to make their systems more and more resilient. So
Right.
chaos testing essentially is the practice of testing or having a controlled blast radius
Mm.
and relating this chaos, right? You bring down one network or you bring down one VM and observe what happens and how your system recovers, or find ways to make your system recover. It's a part of resiliency. You're making it, trying to, through chaos testing, you're trying to make your application more and more resilient.
So, Mrinal, we have talked about a lot of things into the performance part, but I want to, I mean, know the strategy, how we can convince our managers or I mean management for the performance testing in the current project? I mean, is there any way to convince them? And I mean, I want to know how exactly you convince them.
Yeah. So it doesn't, I mean, when you are under the pressure to deliver, right?
Right.
QA is everyone understands, okay, some functionalities you cannot, if some functionality cannot be used,
Mhm.
it will directly have an impact on the business, right? But performance, people don't perceive it so easily. When it happens, only then it is taken seriously. When some performance problem happens, only then it is taken seriously. So
They are Mr.
you
India.
have to, sorry?
They are Mr. India. Hidden gems.
Yeah, yeah. Hidden. Yeah, exactly. So you have to be able to paint a picture of that thing happening to your whoever is your stakeholder. You should be able to tell that if some crash happens due to your performance, due to some performance bug, it not only affects the company's reputation, it also affects how long people will not be able to use the application.
Right.
You gave an example earlier, right? Because performance team runs tests, it brings down the environment, and QA and automation teams are not able to use the environment.
Right.
If performance testing is not done and it is and the code is sent to production,
Mm.
some performance bug may bring down the application, and customers may not be able to use the application for hours together, right? So it's a not just a risk to revenue, but also a reputation risk. This alone should be able to shake people into action, is what I feel. So that is what I do, use to people at my workplace. I tell how it impacts our business, our revenue, downtime.
Hmm.
That helps me.
So, Mrinal, I mean, from 2010 to 2025, I mean, you have explained the entire evolution of this performance testing. Now, I want to know the future of performance testing. I mean, because AI, told me that some plugins are there, right? So, in
Mm.
this AI world, or I can say in next 5 years, how performance will move further, and what should be the next strategy for the performance engineer, as well as if someone wants to start performance testing. Again, there must be some different strategy for I mean for the upcoming 5 years, definitely, right? So can you
Mm.
just share your thoughts on that part?
From what I have seen,
Mhm.
the trend is, I mean, it's a human tendency that, okay, there is a performance problem, throw hardware at it, right?
Right.
But that is not going to solve your problem. And even AI will help you to make your performance testing faster. So I think AI will play a major role in speeding up performance testing. But as long as performance testing itself is not thought of as something important, it is not useful. So in the next 5 years, I think focus will be on improving the speed of performance testing. Like you need to be able to deliver results faster. For
Faster.
that, you need to, yeah, for an engineer who wants to get into performance, focus is on knowing your application better, application architecture is done, all of the things that I mentioned previously
Mhm.
in terms of that has to be known. That will only help you better, that it'll help you to use the available tools like AI too. So the expectation going forward from performance engineers is that you enable people to do things faster, not just you do it, you run the performance tests faster and faster, meaning churn out results faster and faster. Expectation is also going to be that you enable others to do performance testing on their own, right? You have to be able to transfer that knowledge to others so that they are able to do performance testing on their own. I think it's more, the industry is moving more towards enabling developers to do their own performance test, and AI being used to speed up the whole process of performance testing.
So, I mean, Manal, in this entire episode, you have told us a lot of tools, whether it's a commercial or it's a open source, right? So I feel that
Mhm.
you always stay ahead. I mean, in this performance domain, right? So, what all your learning resources? How exactly you learn and know about what's going on into the performance world, so that our audience can also track those resources to upskill them and to know about the trends and techniques which are going into the performance world.
So to be updated, I follow a lot of people in this area.
Mhm.
My favorite people in the performance domain are James Pulley.
Okay.
He's the godfather of performance. He has his own podcast. It's called Perf Bites.
Okay.
So I started listening to that from the beginning. They started out in 2014, I think, 2013, 14.
Mhm.
And I got to their podcast in 2020, I feel, or 2019, I guess.
Right.
So their episodes have, like, they explain all the core concepts of performance testing in very simple terms, right? That is why I started liking them and following them.
Mhm.
For other sources, I would say, generally connecting to people who are in this field helps a lot.
Right.
I've discovered a lot of tools because people share them on LinkedIn. Like I said earlier, Naveen, right?
Right.
I got to know about K6 because he shared one post about K6. People keep sharing on social media, especially LinkedIn. That is how I keep up with all that is happening in the industry. You can follow not just people, you can also follow tool vendors like Grafana, who is the creator of and who owns K6. You
Mhm.
can follow, there are developers who contribute to JMeter, BlazeMeter.
Mhm.
So I would say I always keep up with the what is happening in my area through following people on LinkedIn, following people and companies on LinkedIn.
Manal, I guess we have covered a lot of stuff, and I just want to thank you before wrapping up this entire episode. So, thanks for sharing your journey, your learnings, tools, and tactics with our audience. And I'm sure once audience will go and watch this episode, they will learn more about the performance test, and they will explore all the resources and all the tools, all the members which you have named out. So definitely, it will help others.
Thank you for inviting me to your podcast, Srikant. Because, as you said, there's not a lot of information on. There may be,
Yeah.
but every bit of information adds to what is already there, right? So, thank you for inviting me, and I hope I've conveyed my thoughts good enough for people to be interested in performance testing. People can reach out to me on my LinkedIn if they need to understand anything or if they have any questions. So I'm always open to answer questions. Thank you for inviting me again.
Thank you. Thank you.